Hi guys, and welcome to the video. In this video we're going to be looking at graph traversal algorithms, again in line with the AQA A-Level Computer Science spec. In the top right hand corner you'll be able to spot the reference to the official specification that the exam board provides, that both referencing the content for this particular topic and also any additional information that you need to know, most of which is going to be covered inside of this particular video. So, moving on to the first slide, and graph traversal algorithms, we'll start with those two ways to traverse a graph so that every node is visited. Each uses a supporting data structure. We're going to be looking at two different types. We're going to be looking at depth-first traversal algorithms initially, and then we'll be looking at breadth-first traversal algorithms after that. With the depth first, we are essentially making use of the abstract data structure of a stack. It's considered to be a recursive routine, and the way that it behaves is it traverses along one path initially before then looking back, and then it backtracks again before then going off on a slightly different tangent. So we're going to look at that in an example. Here you've got a series of 6 nodes. On the left hand side we've got an empty stack table which we're going to talk about as we go through this, but the idea here is that with each node being visiting, it is then being pushed onto should I say, the stack, and then being popped off of the stack once all the connecting nodes have been visited. So you'll see here that we're going to begin with node A, and from node A we can then traverse to node B, and at that point B being visited as an endpoint in this particular graph. It doesn't have any connecting nodes to it. It means we can then sort of begin to backtrack. You'll notice then that B is pushed off of the stack as it's deemed as being a fully traversed node. You'll notice that that's now being populated in the table on the right hand side of the screen, before then moving on to C, which is another connected node of A, before then moving on to E, which is another connected node of C, before then F, which is another connected node of E, before then backtracking and pushing off of those values, before then finally arriving at D. What you should spot from here is that once that's completed, D, C and A are then removed from the stack, popped off of the stack, leaving you with your fully traversed table on the right hand side. So breadth first works slightly differently. It makes use of a QADT, or abstract data type. It's a procedural routine, so there's no opportunities for recursion inside of the way that this behaves, and it traverses every edge to each node one at a time. So again, very similar setup, identical graph. On the left hand side you've got now a QADT being represented with the table, and on the right hand side you've got another traverse table. First thing that happens is that we get to node A, again the same starting point. We then traverse from there onto B and C because they are essentially being connected to A. They are all nodes that can be seen from the position of A. From there we then remove A because we've identified essentially the 2 connecting nodes from A. There's no others to look at. We then remove B because B has no others connected to it either, which leaves us with C. And with C you'll notice that we've got D and E. So D and E are now pushed onto the Q as well. We then look more closely at C, and there's nothing else to see, so we can move that off of the Q itself, and we've now fully traversed our graph because from E we can now then spot F before then removing E, removing D because there's nothing connected to that, and finally removing F because equally there is nothing connected to F either. Thank you very much, and I'll see you on the next video.